The huge amount of brain devoted to the hand has been vital for our evolution from our clumsy ancestors, and its devoted to the hand has been vital for our evolution from our clumsy ancestors, and it's led to some of our greatest cultural achievements.
If you want to try and look for... Actually, we do have a...
To monitor our muscles, we rely on our vigilant sense organs. Each is connected to its own region of the brain's cortex. The eyes send signals to the back of the brain, along nerves that cross over on the way. Where we see the world is strangely furthest from the eyes themselves. When you see something, electrical signals race along these pale nerve bundles. They carry coded messages through the brain's massive hemispheres to the back of the cortex. This scan shows electrical activity in the part of the brain where the messages are received. The ear keeps us in touch with every sound and with messages from our fellow human beings. Sounds are amplified and detected by a natural microphone. Its signals, more sensibly, are analyzed in a region of the brain right next to the ear. Smells are conveyed by invisible molecules to the back of the nose. They trigger nerves that fire straight into the depths of the brain, where our emotions reside. That's why smells can trigger long-lost feelings and other memories. Here, a sniff of perfume lights up several parts of the brain. The visual region at the lower right is recalling a view associated with the smell. The unconscious pathways that link our senses are still largely unexplored, and we don't understand how the cortex ties together its scattered responses to our different senses to create a seamless image of the world around us. Most things we do involve almost every part of the brain.
Tell me all the meanings of law in English.
Even something apparently as simple as answering a question.
Yes?
We must hear the words, understand them, draw on our memories, and then voice the answer.
Anybody help?
Because it reinforces particular pathways through the brain, language has molded the very way we think. This area organizes our thoughts according to the rules of grammar. It sends signals to the region which coordinates our breathing, vocal cords, tongue, and lips to allow us to speak.
Conmigo. Muy bien, perfecto. Now we're on a conjugation round.
Language helps us to learn new facts and new ideas. But we can't recall everything we were taught at high school. The brain is selective, choosing what seems to be important, and it stores information in two stages. First is short-term memory. Hear a new word, and you can recall it for a few seconds, but it will quickly fade unless it's filed in the long-term memory.
All has to be right for the point. Who shall I choose? Desesperados? Corey.
Traduzco, traduces, traduce.
To retain what you've learned, the brain must build up permanent new connections between its nerves. The actual structure of the brain changes subtly each time we commit a new fact to our long-term memory. New links are forged throughout the brain, but it's still a mystery how we can recall these dispersed memories at will. With constant repetition, memories become more deeply ingrained. The brain can teach itself by repeating words and facts mentally. Remarkably, the technique also works for physical skills.
Hey, Mr. Johnson, Mrs. Johnson, yours. Perfecto.
The human brain is our most wonderful and our most mysterious organ. Scientists have yet to learn the function of every fold and crease, and how this mass of nerve cells creates intelligence, consciousness, and self-awareness. A computer that can think, let alone be aware of itself, is still far off in the realms of science fiction. Yet each one of us contains a far more powerful computer than any space-age instrument. The human brain has the ingenuity to take us to the furthest corners of the earth and beyond. Its mental reach knows no limit. With our flexible brain, we can look beyond our own world and contemplate the infinite.
A surgical team has assembled here to operate on the most complex structure known to humanity, a human brain. The patient in this case is a 20-year-old woman with epilepsy. She is subject to what could be called electrical storms in her brain, which cause seizures. The surgeons must locate and remove the source of the storms. To do so, they conduct a careful exploration using electrodes on the surface of her brain. The electrodes detect the electrical activity of various areas. This activity is then recorded on a graph and displayed on a video monitor to be interpreted by the surgeon and other doctors. Unusual recordings tell the team where the focus of the epilepsy is. This procedure demonstrates that the brain has an organization that can be explored, no matter how formidable the task may seem. The human brain is, after all, a structure made of proteins, fats, water, and other chemicals. An average adult brain only weighs just over 1 kilogram and has the consistency of thick blancmange. It's part of the body's nervous system and coordinates our actions, allowing us to interact with the environment. The fundamental working units of the brain and nervous system are cells called neurons. The brain alone has 10,000 million of them. The task of each one is to generate, to receive, and to send impulses. We can think of these impulses as traveling in two ways, electrically and chemically. In essence, our thoughts are the results of these impulses. A typical brain neuron consists of a cell body, a set of receiving branches for incoming impulses, and a major sending branch for outgoing ones. The electrical impulse begins when a receiving branch is stimulated. The impulse travels through the cell body and then along the sending branch. When it reaches a junction with another cell, it stimulates the release of a chemical transmitter. This chemical crosses a fluid-filled gap called the synapse to be received by the next cell. It can then cause that cell to fire, as in this case, or it can prevent it from doing so. Dozens of transmitter chemicals have recently been discovered in the brain. A deficiency of a transmitter chemical called dopamine in a part of this man's brain has given him a mask-like expression and a tremor in his limbs. These are the symptoms of Parkinson's disease, which is fairly common in older people. Insufficient amounts of dopamine are produced. In some cases, the patient may be treated with a drug called L-Dopa that in effect replaces the transmitter. We can go back to the brain surgery to demonstrate the electrical nature of the nervous system.